Hey everyone, ready for another deep dive?
Always.
All right, well today we're going to be tackling wave superposition.
Oh, cool.
Yeah, and to help us out, we've got this really interesting educational simulation.
Oh, nice. Where's it from?
It's from a site called Open Educational Resources, Open Source Physics at Singapore.
Okay, cool.
Yeah, and we're going to try to figure out not just what wave superposition is,
Right.
but also why it's such a fundamental concept in physics.
Yeah.
And even maybe where you might encounter it, out there in the real world.
Yeah, it's pretty wild. It pops up everywhere, like literally everywhere.
So let's start with the basics. What exactly is wave superposition?
Well, at its heart, it's just about waves coming together and how they interact.
Okay, so they combine, but what happens when they do?
So imagine throwing a pebble in a pond.
Uh-huh.
You get ripples, right?
Yeah.
Now throw in two pebbles.
Okay.
You got two sets of ripples, and where those ripples overlap, they kind of dance together.
They add up.
Yeah, exactly. They add up. It's not that the waves disappear or destroy each other.
Right.
They combine and they create this totally new wave.
Okay.
And sometimes it gets pretty wild.
So with this simulation, it actually lets us play with the initial waves,
Yeah.
right? Like their size, how fast they're vibrating, even their length.
Yeah. Oh, that's pretty cool.
Yeah.
Mm.
So we can see how messing with those properties changes their combined form.
Mm.
What kind of interesting things, what outcomes should we be looking for when we're playing around with this?
Well, sometimes, they'll combine and you get a wave that's way bigger than either of the original ones.
Oh, wow.
Like they're joining forces. But other times they kind of work against each other and cancel each other out.
Really?
Yeah. That's called destructive interference.
Huh.
And that's like the science behind noise-canceling headphones.
Oh, wow. Okay. I'm actually messing around with the simulation right now, and I'm noticing that when I change the frequency of one of the waves, the whole interference pattern, goes nuts. What's up with that?
That's because you're basically changing the rhythm of the dance between the waves. Think about the ripples again.
Okay.
If you have one set of ripples coming in fast and close together,
Uh-huh.
and the other one's more spread out and chill,
Yeah.
their interaction gets super complicated.
Right.
You'll get spots where they consistently clash and cancel each other out.
Okay.
Those are called nodes.
Nodes.
Yeah, and then you get other areas where they totally sync up, and just boost each other.
Oh, interesting.
Those are antinodes,
All right.
like maximum energy zones.
So it's like this push and pull between the waves.
Exactly. And that push and pull can lead to some pretty cool phenomena, like standing waves.
The standing waves.
You know those waves you see on a vibrating guitar string?
Oh, yeah. Okay.
That's what's happening there.
Wait, so the sound of a guitar is basically just wave superposition, carefully choreographed.
Pretty much. You pluck the string, you create these vibrations that travel up and down.
Yeah.
And the way those vibrations interfere with each other, that's what creates the specific sound of the instrument.
No way.
Isn't that neat?
That's super cool.
Yeah.
So we talked about sound waves, but you mentioned that this happens with light too, right?
Oh, absolutely.
And I got to admit, my mind is a little blown by that.
Well, remember, light travels in waves too.
Yeah, okay.
And just like sound waves, light waves can interfere with each other.
Uh-huh.
That's what gives us all this awesome colors we see.
So you're telling me that all the colors we see are just light waves, like doing their little superposition dance?
Pretty much. Think about a soap bubble.
Okay, yeah.
You see all those swirling rainbow colors on its surface?
Yeah, totally.
Those are created by light waves bouncing around inside that thin film of soap.
Oh, wow.
Some wavelengths get amplified, others get canceled out, and boom, you get those crazy colors.
So the soap bubble is like a tiny wave superposition arena.
Exactly. And you see the same thing with oil slicks on water.
Oh, yeah. Okay.
The way those colors shimmer and shift, all thanks to light wave interference.
This is blowing my mind. So how is this used in actual technology? You mentioned something about that before.
Oh, tons of ways. One of the coolest, though, I think, has got to be holograms.
Oh, cool.
You know those 3D images that look like they're just floating in space?
Yeah, yeah.
They're made with lasers.
Really?
Yeah, and you guessed it, wave superposition.
Wow.
The laser light, it gets split into two beams. One bounces off the object and the other acts like a reference beam.
Okay.
When those beams come back together, they make this interference pattern. And that pattern stores all the information about the object's shape, its depth, everything.
So they're basically freezing the wave superposition.
That's a great way to think about it. And that frozen pattern is what lets us see the object in 3D.
Okay, so we've covered sound waves, light waves, holograms. But you said earlier that this wave superposition thing is happening all the time, all around us, right?
Oh, absolutely.
What are some other examples that we might see in our daily lives?
Well, let's go back to those noise-canceling headphones you mentioned earlier.
Yeah.
They're like a perfect example of destructive interference in action.
Huh.
But they don't just like randomly block sound.
Right.
There's actually some serious tech going on in there.
Okay.
So first, they have these teeny microphones that pick up the sound waves coming in.
Oh, okay.
Then they create a new wave that's perfectly out of sync with that noise.
So, like, the opposite.
Yeah, exactly. And when those two waves collide,
What happens?
they cancel each other out. Poof. Silence.
So they're fighting fire, but with sound waves.
Exactly. It's like a sonic battle, and silence wins.
That's amazing.
Yeah.
But there's got to be limitations, right? Like, they don't block out all noise.
You're right. They work best with those constant low-frequency sounds.
Okay.
Like the rumble of a plane engine or something.
Uh-huh.
But they have trouble with those sudden high-pitched noises, like, someone yelling or a baby crying.
Yeah.
That's because those sounds have much shorter wavelengths.
Okay.
And it's harder to create that perfect anti-noise wave to combat them.
Right. So besides annoying babies, are there other limitations? Like, what are the challenges of designing these, like, sonic warriors?
Well, you got to make sure the headphones create the right kind of anti-noise, but without adding weird distortions or echoes.
Oh, right. Yeah.
And they have to be comfortable to wear, too, right?
Yeah.
Which can be tricky when you're packing in all that tech.
Yeah, that makes sense. So where's this tech going? Like, will we ever have headphones that can block out literally everything?
That's a good question. Researchers are constantly working on improving it, new materials, algorithms.
Wow.
Who knows? Maybe one day we'll have personalized sound bubbles that just filter out what we don't want to hear.
That would be amazing. Imagine walking down a busy street and just hearing birds singing. So from headphones to holograms, it seems like wave superposition is pretty key to a lot of modern tech.
Totally. But it goes even deeper than that, I think.
Really?
It helps us understand, like, the very fabric of how the universe works.
Right. Ah.
How energy travels, how it interacts, from the smallest particles to, like, huge cosmic structures.
No, it's not just some physics trick. It's fundamental to how things work.
Exactly. It's like this beautiful example of how simple rules can create incredible complexity and diversity.
I'm starting to see the world in, like, a whole new light, literally. This deep dive has been amazing.
And we've just scratched the surface. There's so much more to explore, but I think this gives you a good foundation for understanding, like, the power and the beauty of wave superposition.
I'm definitely feeling way more wave savvy. So, before we wrap things up, is there anything else we should touch on?
Yeah, no, it's crazy, right? Like, I always thought colors were just, well, colors.
Right. Not some, like, crazy light wave thing.
Yeah, exactly.
But it's all about the waves. Okay, so you were talking about how wave superposition is used in technology.
Oh, yeah, for sure.
What are some of the ways we might encounter it, like in our everyday lives?
Well, remember those noise-canceling headphones we were talking about?
Oh, yeah.
They're a prime example of this whole destructive interference thing in action, but there's, like, a lot of tech packed into those things.
Right.
It's not just random blocking of sound.
But how do they actually work?
Okay, so they have these little microphones, right? And those mics pick up the sound waves that are coming in, all the noise.
Right.
And then, get this, they create a new wave that's totally out of sync with that noise.
The opposite.
Yeah, basically. So when those two waves collide, boom, they cancel each other out.
That's so cool.
It's like fighting fire, but with sound.
That's a great analogy.
Right.
But they don't block out everything, right? There are limits.
Yeah, definitely. They're better at dealing with some sounds than others.
Okay, so which sounds are they good at blocking?
Mostly those constant low-frequency sounds, like think of an airplane engine, that kind of rumble. But they have a harder time with sudden, sharp sounds,
Oh.
Things like someone shouting or, well, that baby crying we were talking about before.
Oh, right. Those high-pitched sounds.
Yeah, exactly. Those sounds have much shorter wavelengths, so it's way harder to create that perfect counterwave.
That makes sense. So, are there any other limitations to this technology? Like, what are the challenges in designing these, sonic warriors?
Well, one of the big things is making sure they create the right kind of anti-noise, but without adding any weird distortion or echoes.
Right, so it has to be clean.
Yeah. And of course, comfort's important too, right?
Yeah, for sure.
Which is tough when you're trying to cram all that tech in there.
It sounds like a real balancing act.
Yeah.
So where is this technology going? Like, will we ever have headphones that can truly block out everything?
That's the dream, isn't it? Researchers are always working on making them better, trying new materials, new algorithms. Who knows, maybe one day we'll have personalized sound bubbles. Like, imagine that.
Yeah, that would be incredible.
Just filter out whatever you don't want to hear.
So from noise-canceling headphones to holograms, it seems like wave superposition is pretty crucial to a lot of modern tech, right?
Totally. But it goes even deeper than that, I think.
Really?
It helps us understand, like, the universe at a fundamental level. How energy travels, how it interacts, from tiny particles to massive cosmic structures.
So it's not just like a neat trick. It's core to how everything works.
Exactly. It's kind of amazing, right? These simple rules can lead to such incredible complexity.
Yeah, that is pretty mind-blowing.
Like, the universe is this crazy symphony of waves constantly interacting, and that's how we get the world we experience.
I'm starting to see everything differently. This deep dive has been amazing.
Yeah, and we've just scratched the surface. There's so much more to explore.
I can only imagine.
But I think this gives you a good foundation, a way to start to understand the power and the beauty of wave superposition.
Yeah, for sure. I'm feeling way more wave savvy than I was before. So before we wrap things up, is there anything else we should cover? I feel like we could keep going, but yeah, we should probably wrap things up soon.
Right.
So for someone who's not, a physicist or an engineer, why should they care about this wave superposition stuff?
That's a good question. I think for me, it's about seeing the connections,
Connections, yeah.
Like physics, music, color, technology. It's all linked by these basic principles.
Right.
It kind of reminds you that the universe is like this giant symphony of waves. They're always interacting, and that's what creates everything we see and hear and experience.
That's a really cool way to think about it.
Right. We're all just riding the waves.
So, to recap, we've been talking about wave superposition. We used that awesome simulation from Open Educational Resources Open Source Physics at Singapore. We saw how waves combine. Sometimes they get bigger. Sometimes they cancel each other out. And we learned how this one idea explains so many things. The sound of a guitar, the colors of a soap bubble.
Even those noise-canceling headphones, those sonic warriors, turning noise into peace and quiet.
It's amazing how much we covered, all from this one concept.
Yeah, and remember, this is just the tip of the iceberg.
Right.
There's a whole universe of waves out there. But now that you have this understanding of superposition, start paying attention.
To what?
Everything. Listen to the sounds around you, look at the colors, think about the tech you use.
I bet there's a lot we miss.
Oh, yeah, totally. You'll start to see the world in a whole new way.
Maybe even dream about interfering waves.
Maybe.
But seriously, folks, keep those brain waves rippling and never stop exploring.
Well,
until next time, happy deep diving.